Okay. All right, here we go, fourth hour. Say good morning, fourth hour. Fourth hour. Good morning. And don't say the fourth hour part. What the heck was... I don't know what that was. Okay. So I hope you didn't write this down. You already did, didn't you? When I say inverse, you say domain, and range x. I took that from Cooper. Cooper always got mad at me. You know who had Mrs. Cooper? All right, anyone? Mrs. Cooper? No? What? I thought that was impossible. All right, she would get mad at me when I would say, when I say inverse, you say switch x and y. And she's like, there's more to that. All right, it's not just x's and y's, and yeah, she would yell at me. So, and that's fine. So I take her domain and range exchange, but ultimately that's what we do. And I told you to do 10, 11, and 12, right? And I just verbalize, oh, we got some scary eyes over there. I just told you to switch x and y and then resolve for y, and then hopefully you get some good answers there. Now we're gonna delve into the what happens and some more relationships. And this is fourth hour on our homecoming week. If I use this video in the future, this is 2019. I lost my 2013 videos over the summer with what's it called, YouTube. So yeah, I have to start making fresh ones, I guess. Okay, so it does say give the domain, and actually we're going to give the range of both as well. Because when I say inverse, you say domain and range exchange. It means x and y is switched. It also means domain and range is switched, which actually that's a synonymous statement. That's a similar statement there. So what I told you to do yesterday, first of all, that's a line. So the domain of that line is infinity to negative infinity. Reverse that. I said that in the wrong order. And then the range is also, right? All y values and x values covered. We're actually going to graph that, but not yet. I'm going to do what I told you to do yesterday. When I say inverse, you say, okay, we'll do the Samuel's thing. Switch x and y, and then resolve for y. So again, this is a college note-taking thing, plus I'm making a video. Am I taping? Oh, thank the maker, if there is one in a public school. All right, and then subtract 5. And then the way I'm going to write this, we're in CAT. We should be able to write this right now. Instead of y, we'll call it the inverse of f of x, which looks like f to the negative first. This is a Mickey Mouse example. And then this is so simple. And I'm going to divide by 2, and I'm going to divide by 2 like this. Divide by 2, divide by 2. Then that shows me the slope and the y-intercept. What I'm going to do, go ahead and do this, because as we go through the notes at the end, I was going to talk about graphically what do we do. But I'm going to graphically, because we have the time, homecoming, full schedule, fourth hour. 7th doesn't have the luxury. 7th, you're going to have to watch this melodious video, listen to my voice. Y-intercept is negative 2.5. Oh, this is going to be a pain to graph. So the red will be the inverse. And then the slope is 1. If you don't know how to graph a line and you're in my class right now, you are severely behind. And that's what I'm getting. All right, and that's hopefully we go through that process. Remember I talked about the Common Core copying thing? I don't know how I have students that can't do a 2-step equation, still can't graph a line, blah, 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 blah. Better get there. Hey, we're still covering it again. This is the 5th time in this class I've covered how to graph a line or talk about equations of lines. So even though I lament that, these students don't know what they're supposed to know coming into my class, I'm still going to cover it. Just like factoring. I swear to dog, if you can't factor by May when we're done with this class, I have no idea what we're doing in here. All right? Factoring. You should already know how to do that. I'm going to factor. Why is he complaining so much on this thing? All right. Now I'm going to graph that in blue because I want you to see a relationship right now. 0, 5. 1, 2, 3, 4, 5. Y-intercept of 5. How is he doing that? Oh, you're killing me if you don't know how to graph a line. Drop 2 and run 1. Not rise 2, run 1. I want to come closer to the other line. So I did negative 2 over negative 1 for the slope. The number in front of x is the slope. Huh? Okay. And then drop to run 1. I guess I didn't really show this first hour, but drop to run 1. And then we should see that this point actually goes through, guess what? Negative 2.5 on the x-axis. That's interesting. And then this one goes through negative 2.5 on the y-axis, huh? Hey, this point on the red one is 0, negative 2.5. This one is negative 2.5, 0. Because when I say inverse, you say switch x and y. And now watch when I draw this. I'm going to do it in orange because it looked pretty good in the other class. Do you know what this line is? That is the y equals x line. And I'm going to verbalize this. When I have an inverse, the graph of a function and its inverse will always be there are reflections across, that's the reflection sound, reflections across the y equals x line. Write that down. And then I'll press the pause button for a second, give you a break from my voice. Although on YouTube, it's just going to start up again. So remember this, we just talked about if we continued the rise over run, this actually would be at 5-0, because I'd rise 1, run 2, and then it would, this is like 4, 5, then, yep, or, yeah, no, this is what, 4.5, right? This is at 4, never mind, that would have happened, just trust me, all right? Trust me. All right, because switch x and y, 0, 5, 5, 0, switching x and y. But anyway, reflected over the y equals x line. Okay, here we go. And then I have this graph for you, and I'll explain it. And I'll do this one. I guess I'm doing the originals in blue. This is actually, don't get confused how this is written. It's written in like old-fashioned calculator form when we didn't get the new upgraded fancy calculators with the fraction button. You know, that's how we would have to type it in y1. X divided by parentheses x plus 1. And then I'm going to use this graph up here, so you put it wherever you want. As you're writing the notes down, we are going to find the inverse of this in a moment. But I wanted to think about domain and range. And by the way, the domain and range of this previous one, the inverse is still negative infinity to infinity for both, right? For the red. Okay, so this one, make sure I do domain and range for these, which I will. Okay? All right. So first thing, here we go, review. All right, and it's actually a review of this chapter, the whole idea of asymptotes. Why do we have an asymptote at -1 for x? Because we can not divide by 0, and then that creates an asymptote. Then why do I have looks like a horizontal asymptote at 1? When I plug a million, what's a million divided by a million plus 1? It's not a million. Sorry for yelling at you. Remember, it's like ripping off a Band-Aid in this class. Wrong! Got to exercise that bad math out of his brain. What's a million plus divided by a million plus 1? 1. End behavior asymptotes. Same thing with negative a million divided by a negative million plus 1. It approaches 1. So that's why we see this behavior. This is the graph of that. Maybe I should put this one in red. Yeehaw! All right, let's see if this works. It didn't work the other day. Son of a nutcracker. I used to be able to surround that and make that red. All right, so the blue graph is graphed in red, and then when I find the inverse, the red graph will be graphed in blue. This is going to be fun. Oh, no, I'm sorry, right? Can you just... No, I'm going to stop saying it. Okay, so wherever there's an x and a y, what do I do? When I say inverse, you say switch x and y. So this is y. Now it turns into x, and I swear to dog, I have already taught you how to do this. If you were going to say, holy cow, this class is too... You've already done this in the past, and we've already taught how to solve for y in Chapter A and P. So, again, for notes purposes, like this is a college, you just got to sit there and listen, not discovering like that Common Core communism copying thing. All right? How am I going to solve? I'm first going to... Why did I put this x over 1? So I could cross multiply. So y times 1, which is y, and then x times y plus 1. And then remember what I did on this? Hold on, I have to solve for y. By the way, if you did this, get out. All right, sorry, I shouldn't say that, but That's a 6 over 5 equals 2 error, isn't it? Right? And you can't lose your y's anyway. So can't do that. And then highlighting this, oh no. Right now, listen, you're in cat. You don't do nothing. You do something. So how am I going to get these y's together? Well, what do these parentheses imply? At least try what? Multiplying, which is what? Distribution. And then you get y equals xy plus 1. And then I keep doing this because this is what your brain should be highlighting. I wasn't done yet. You know, everyone's so impatient. Jeez Louise. Would you just relax for a second? All right. Then those y's are, that was a mistake. All right. What do I do next? Who knows? Who remembers from the other? I know your name. It starts with an A and then a K. All right, go ahead. Oh, no! Now, you know why you don't divide by y? Isn't this fun? Because then you'd have this. And then you'd have this, and you're like, oh, no, right? Because division is distributive, and I like covering common mistakes. Don't feel bad. Remember, look at this corner. We make mistakes. Never, let the fear of striking out make you stop swinging. You factor out the. Oh wait, you're not ready to do that yet. You had one step. Go ahead over there. Subtract the. I would rather actually subtract the x, y from both sides, and then you have the y's on the same side in one step. You could have subtracted the y and subtracted the x. You got to get the y's on the same side, one way or the other. Then what did you say? What did you say? Someone said it over here. Starts with an F and ends with actor. I have no chance. No time. Factor. What? Okay. Y. And then what's this become? People. What? When I take a y out of that, what does that become? 1. People lose that. 1 minus x. And now 1y has occurred. We got y by itself by the glory and power of factoring. Right? And then what do? You divide by. Now remember what I said. You know what? And when we do that last step, let's turn that into the function notation. The inverse, we're only halfway through, right? Did you hear that bell? For half the day today, I thought today was Friday. I have no idea why. Oh, okay. Remember what I said? We're going to graph this in blue. No. We're going to actually find the domain and range and then graph it in blue. What's the domain of this one? What can't x equal now? What can't x equal now? 1. Do you know what x could not equal in the original? No, wrong. Do you know what y could not equal in the original? 1. The original's range, I know where the colors are all screwed up. The original's range was the horizontal asymptote. So, again, inverses domain and range exchange. Then going back to blue, what's the range? Well, let's analyze. What happens when you plug in a million? What's a million divided by 1 minus a million? What does that make the denominator? What kind of number? Negative, but essentially still negative a million. What's a million divided by negative a million? Negative 1. You were going to have a... No, I hope not. He said heart attack. That's not funny. You probably just let me lay on the ground. Oh, free class. Do we have to stay? No, let's just all leave. Okay, hold on. We have a question. Guess what? The domain... A chicken butt. That's an old reference. I remember that one. The domain of the original is the range of the new because we said in the original up here, sorry for my colors, I just don't like the colors not meshing with the, x could not equal negative 1 in the original, and then lo and behold, y can't equal negative 1 in the inverse. So remember I told you, the inverse we're going to graph in blue. This program won't let me change the colors. So I'm going to graph this in blue up there. Okay, so we have a vertical asymptote at x equals 1 for this fumble. Now, you are going to have to do this on your worksheet. On the back, it's all inverses, and I ask you on the last two questions or more, at least two of them, that you graph the inverses. And it's actually a review of this chapter. But we actually do these more in Chapter 2 as well, these rational functions. So I'm taking my time. I don't care. I don't care. All right? We really have to cover these things, and it's your job to actually focus, pay attention, and have the gumption to, care, I guess. And then, hey, this point 0, 0. How did I get that 0, 0 in the original function? All I did is plug in 0 for x. What's 0 over 0 plus 1? 0! So I plugged in 0 for x, and I got 0 for y. And then the same thing with this one. What's 0 over 1 minus 0? So the new function and the old function share that point. Are you okay? That kid just banged his head off the desk. Okay? Sorry my voice does that to you. All right? And then, I know it's hard to see the blue, but this is the other part. I know that just because I know how these functions work, and I also know this. Sha-na-na-na-na-na-na-na-na-na. Look at this point. Sha-na-na-na-na, all the way across to that one. Da-da-da. And you know what these are inverses? You know what happened? They are reflections across the y equals x line. I know there's a lot of dotted lines there, but do you see that? Y equals x line, they are definitely reflections of each other. Okay, anyway, let's move on. We'll take a break for a second from my voice. Okay, here we go. All right, let's try to keep this red original, blue new. Yeah, okay, got it. So I know it. What's the domain of this? Because we want to know that so we understand domain and range exchange. What can I plug in for x for this situation? -2 is definitely the beginning point of this. To infinity, what should I have on -2? A bracket, because yes, you can take the square root of 0. What kind of output do you get? Don't change colors, I was about to. What kind of output? What's -2 plus 2? 0. What's the square root of 0? Your range is 0. This is an important one. And I think we had this in writing, not my writing. Some other teacher made these notes. I just keep them because they're fine. Any restrictions inherited. That's what this says in that cursive writing. Including any restrictions inherited from f of x. We got to be careful when we do inverses. This is the beginning of your world about restricted domains. All right? Because, I'll tell you, the new function, the domain will be 0 to infinity. Right? Domain and range, say it. Domain and range, say it. Exchange. And the range will be -2 to infinity. And you're not going to agree with that when we see our answer. But you have to. And actually, we have to see the graph to make this happen. Because this came from an inverse of another function that has restrictions. It's really the best way. And then when I say inverse, you say switch x. Well, the math is going to be so easy with this. By the way, can I subtract 2, which I have people do all the time? This is the ones I can't help you. There are so many mathematical errors going on that have nothing to do with me being a crass, old, jerk teacher. They're inherited from what you came in from your other classes. And we're going to have to do everything we possibly can to get those things out of your brain. No, you cannot subtract 2. You square. And again, this is my whole point about the sitting in groups thing. If I give you a key online, don't just have it open and stare at it, because you're not doing anything. You're not doing the math. I did the math, and then you're copying it down. Sure, you say to yourself, oh, okay, I get it. You didn't let your brain struggle. You didn't create that wrinkle. Hey, what's x squared minus 2? What is that? What's that a picture of? A full-blown what? Parabola. Is the top a parabola? No, we should know that the top is -2, 0, and then -1, square root of, and this also infuriates me. How many people on that quiz didn't plug in points? I could see the calculator copiers. That you're at a very low level right now, and you need to either raise yourself up or, I don't know, it's going to be a struggle all year long. Negative 1 plus 2 is 1. Square root of 1 is 1. Having to use a calculator to graph this is infinitely bad. 2 plus 2 is 4. Square root of 4 is 2. All right, and then it's the square root function that you see from your book. I have a hand up. I can't. I gotta. All right, now here's the blue. We all know that the blue. Okay, we should at least know the blue as a 0, negative 2. And we all know the blue looks like this. And I'm going to erase it. By the way, I saw a lot of graphs that look like that on our quiz. You're gone! Okay? Meaning just like scratch, no points, missing key little parts at the beginning. See, you can only graph this based off of the inherited domain and range from the original. Really, the inherited range from the first one, that becomes the domain. I can only graph this parabola using these x values from 0 to infinity. And then you'll see why when I talk about what a graph looks like. Hey, negative 1, 1, 1, negative 1. And that's true actually anyway. 1 squared is 1. 1 minus 2 is negative 1. All right? And then this one is 2, 2. This is 2, 2. 2, 2. So you can only graph that because that's what you had from the original. And then here comes the y equals x line. If you drew the other part of that parabola, the original has no, I guess orange is a really bad color. Looks like red. There's no other part that reflects from the square root to the other part of the parabola. That's why it's imperative you understand the inherited domain range issues. Got it? And then we can play the game. Right? And then this. There's the, okay, you don't like that sound? All right. Yeah, okay, all right. This is not in your function book. Okay, this is not one of the common functions. But I'm still going to graph it. What would be the starting point for graphing this? What would I plug in first? 2. Do you remember that day before the translation day? I said, be smart in how you graph things. And how you graph things is you plug in what makes that 0 on the inside of the function. 2, I get 0. The cube root of 0 is 0. Can I plug in 1? Yes! Kapow! I wanted to scare that out of you. Because what's 1 minus 2? What's the cube root of negative 1? What times what equals negative 1? Negative 1! Okay? So negative 1 times negative 1 times negative 1 equals negative. So the cube root of negative 1 is free. What just happened there? All right, negative 1. So you do get an output value. All right, I wanted to put that on the video. That was a little, my computer always likes to mess with me. All right, so when I plug in negative 1, I get negative 1. And then, of course, I could plug in negative 6. Why would I plug in negative 6? I plugged in 1. I got negative 1. 1 comma negative 1. Sorry, did I say something? Did I say something? We'll have to check the video. They apparently said I said plug in negative 1. I meant plug in 1. 1 minus 2 is negative 1, and then the cube root of negative 1 is negative 1. Now, why do I plug in negative 6? What's negative 6 minus 2, everybody? What's the cube root of negative 8? Negative 2. So this has output values here. Then, of course, 3. There we go again, another mistake. 3 minus 2 is 1. Cube root of 1 is 1. You get this. And then the next good value would be 10. Because 10 minus 2 is 8. And then the cube root of 8 is 2. So you do get this unique picture, which is actually the inverse of a cubed function, which you have that in your book, and we're going to see that here shortly. When I say inverse, you say switch x and y. If Cooper hears this video, she's going to have the shakes. She doesn't like when I say that. How do you free this? You cube it. You don't add 2. That's the bad math. Okay, fine, I referenced it. Don't do that. And if you keep doing it, that's like putting your hand, oh my gosh. Do you know how many people square rooted both sides on the quiz to solve that one question on the written and did not put plus and minus on their answer and get 2 answers? It was over 50%. Wasn't that the burn? thing, and still 50% of the students made that mistake. Urgh. Never. All right, here we go. No, I will. It will definitely be before the test as a review thing, and then 1 cubed is 1, and then this becomes 3. And then -1 plugged in cubed is -1. This becomes 1. And then this is where you get this classic. And then whatever that graph picked that. Oop, I should have went more sloped down that way. I didn't like how I did that end. And then here we go. I guess orange is a bad choice. Maybe green. I don't know. Y equals X line. Definite reflections. Shouldn't it? Why are you? Oh, this touch screen drives me nuts. This computer. I want the one I had 2 times ago. The computer I had two cycles ago was so much better than any computer I've had. There he goes complaining again. Okay, so I only have two. You weren't in the video. I only have 2. Like 4 or 5 minutes left, and I couldn't care less. The assignment is on the calendar. I think I should add one little thing. 1, 2. I should add that there is a horizontal asymptote there. Because then what we're going to do is, and don't worry about all the graphs, we're going to find the inverse of this graphically. By the way, do you know what that is from your function book? That's exponential. That should instantaneously pop into your head that this is an exponential picture. What's the inverse of an exponential? Logarithm. Okay, and that's why when we go into chapter 3, when we really graph logarithms real intense, we hopefully will understand that. So first they say determine if the function's 1-to-1. It's a function. It passes the vertical line test. Does it pass the horizontal line test? Yeah, so what it's saying is I can then find the inverse of this. If it's not 1-to-1, I cannot unless I restrict the domain. It's like finding the inverse of a parabola. I can't find the inverse of this unless I restrict the domain to only consider the part on the right. You understand what happened there? Just like when I took the inverse of that square root. Well, it is 1-to-1, so I may proceed. How do I do that? You make up some things. Like, for instance, doesn't it look like this point is 0, -1, right? And then for theoretical purposes, it looks like 1, 2, 3, 4. This point is -5, comma. Now, wait a minute. The point of an asymptote is it approaches but never crosses what number, apparently? -2. So I'm going to make up something like it looks like, let's just make up -1.99. Just making it up. And this is what you have to do if I ask you to take an inverse of a picture. I don't care how ugly the picture is. Find critical points that establish the shape. And other than that, it's like a Mickey Mouse question. Once I've given you this scenario, 2, 1, 2, 3, 4, 5. I went to Disney this year. Now when I say Mickey Mouse, I get a memory of something. All right. Now remember I said blue. When I say inverse, you say stop making me say it. Switch X and Y. So what's 2, 5 become? 1, 2, 3, 4, 5, comma 2. Interesting. And then understand that at this behavior, it just kept going off. There was no asymptotic situation there. Well, I got people putting their stuff away. All right. And then what's 0, -1 become? -1, 0. And then -1.99, comma -5. And the asymptote is actually here, which is what logarithms have. They have asymptotes that are vertical in nature, not horizontal. All right? So that's what you have to understand. All right, and then what I was going to do, but we're running out of time. Hey, by the way, what's this a function of? What's that a picture of from our book? Square roots. When I take the inverse of this, it'll be half of a parabola, but half because of the restrictions. And then, hey, is this 1-to-1, yes or no? And then I got a hint. Yeah. What is this? Is this one of our trig things? It's the cosine kid. But since it's not 1-to-1, I cannot find the inverse of it unless I restrict the domain. Now I'll show you how that happens, and we'll have to remember this from this point. What you do to restrict that domain is restrict all of that part, because that is now a one-to-one function. You see what I just did there? All right, and then we're going to find out how to do that in trigonometry. So can't find the inverse of this. What I would have done with this as they pack up their bags and ignore me is 1, 2, 3, negative 2. This is negative 3, negative 2. Oh, this looks like we're gonna cheat and say this looks like 1, 0. And then this looks like 5, 1. And then because it's a video, I guess I will find the inverse of this. So now I have 1, 5. I have not 1, 0, 0, 1. And then I have not negative 3, 2, negative 2, comma, negative 3. I feel like I'm going too fast. Negative 2, comma, negative 3. And then it does something like this. It's half of a parabola. Not the other half. Okay? All right. I think that's good. There you go, 7th hour with our short, and we don't even have 31 minutes today.